Good afternoon. Welcome to Women in Preservation. I'm Rachel Patton, Executive Director of Preserve Arkansas. Preserve Arkansas is the statewide nonprofit advocate for historic preservation. I'd like to thank DMX Architecture in Fayetteville for their generous support of women in preservation. Many of you are members of Preserve Arkansas, and we appreciate your support. If you're not a member of Preserve Arkansas, please join us. Your membership is vital to our organization and supports all of the work that we do to save Arkansas's historic places. Plus, membership has its benefits like cool Preserve Arkansas swag and discounts on event tickets. You may learn more and join at preservearkansas.org. We have lots of fun and exciting events coming up in 2026, including preservation crustaceans, our annual crawfish and shrimp boil in the backyard of Clements and Associates Architecture in downtown North Little Rock on Saturday, May the 2nd, as well as our Mid-Mod Arkansas tour, which will be in Little Rock this year and feature designs by F. Eugene Withrow on June the 6th. And we're very excited about this. We will be having an Arkansas statewide preservation conference October 21st through the 23rd in Hot Springs with support from the National Trust for Historic Preservation. And our Ramble bus trip will also visit Hot Springs this fall on November the 7th. And Ramble participants will receive a copy of David Hill's book, The Vapors. And then the Ramble is all themed around sites that are mentioned in the book. So if you're not already a member, then join or renew your membership, or at the very least, sign up for our email list so you'll be the first to know when tickets are available for all of those events and more. And stay tuned on April 14th for Women in Preservation with Heather Davis and Kate East, principals at AMR Architects in Little Rock. And now it's my pleasure to introduce today's speaker, Dr. Emily R. Bartz. Dr. Emily Bartz is the station archaeologist at the Arkansas Archaeological Survey's research station at the University of Arkansas at Pine Bluff. She earned her PhD in anthropology from the University of Florida, her MS at Illinois State University, and her bachelor's from Grand Valley State University. She's conducted field work and research across the eastern United States, including in Michigan, Illinois, Florida, and Arkansas. Her work focuses on archaic and woodland period subsistence practices, pottery and residue analysis, and experimental archaeology. Dr. Bartz's recent research combines chemical and experimental methods to better understand the uses and meanings of North America's earliest pottery and what it reveals about ancient food traditions. Welcome, Dr. Bartz.
Thank you so much, Rachel. And I'm going to share my screen now.
Yeah, okay.
There we go.
Okay, looks good.
Very good. All right. Yes, thank you all for tuning in today. And thank you, Rachel, for inviting me to speak for this Women in Preservation webinar series. Today, I'm going to talk about what I do for a living. This is research that centers on foodways and pottery use in the American Southeast during the archaic and woodland periods about 5,000 years ago to about 1,000 years ago. Before getting into my research, I want to briefly share how I found archaeology and how I became interested in foodways research. I grew up in northern Michigan in a very small town called Alpena, which is located on the coast of Lake Huron. Alpena is pretty small, but it's home to the Thunder Bay National Marine Sanctuary, which is operated by NOAA. That sanctuary protects nearly 100 shipwrecks in Lake Huron and supports a number of scientists working on historical research, collections, and underwater archaeology. Because of that environment that I grew up in, I was introduced to archaeology from a pretty young age. And Alpena Community College, where I started off right after high school, runs an underwater technology program in partnership with the sanctuary, and it trains students in underwater robotics, diving, and gets a little bit into maritime archaeology. At first, though, archaeology was not the plan. Right out of high school, I enrolled in nursing school, but I soon came to realize that I absolutely hated working in a hospital and waking up early. So I took a semester off to think about what I really enjoyed, and what I enjoyed doing was being outside, quite literally playing in the dirt and learning about American history, pre-contact, before Europeans, quote unquote, discovered the continent. And after that realization, I enrolled at Grand Valley State University in Grand Rapids, Michigan, where I began taking anthropology and archaeology courses. When I was there, I completed a nautical underwater archaeology certificate and a training in underwater robotics through NOAA and the Alpena Community College. And it was actually one class away from completing my diving certificate when I realized that I was too afraid of diving to make a career out of it. So I found out that I preferred and loved terrestrial archaeology anyway. And during my senior year at Grand Valley, under the advisement of my mentor Janet Brashler, I wrote a thesis on food storage features in western Michigan. And these are large, what they're called cache pits, and they're essentially underground cellars, and they really fascinated me. Just thinking about how mobile groups organized their seasonal movements across the landscape and stored their food for later use really sparked my interest in archaeology and foodways. From there, I went to Illinois State University, where I completed my master's degree under James Skibo. Jim is well known for his ethnographic work among the Kalinga and the Philippines, and for integrating ethnoarchaeology and experimental archaeology into the study of pottery and foodways. From that, you can sort of see the seeds of my interest growing. And then for my master's thesis, for the research that I conducted, I continued studying food storage pits. This time on Grand Island, which is in the Lake Superior, north of the Upper Peninsula of Michigan. So from there, I went on to the University of Florida, where I earned my PhD under Kenneth Sassman. And Ken is a renowned Southeastern archaeologist, and I had the opportunity to build on his earlier dissertation work by studying some of the earliest pottery made in North America. And that's going to bring me to what I'm talking about today, my dissertation research and the work that has really grown from that, which focuses on early pottery technologies and foodways in the Southeast. Across my research from state to state, a continued thread of what I focus on is foodways and cuisine. And since my earlier work as an undergraduate, I've been interested in how cooking and eating practice structure everyday life and how those practices change as communities reorganize. So you might be asking, what the heck are foodways? Foodways refer to traditions, habits, cultural meaning surrounding food. And it's not just about what people ate, it's not just about diet. It also includes how foods were prepared, how they were cooked, what tools or utensils were used, and which foods were important for ceremonies or special occasions. Foodways really include everything surrounding food, from its procurement and processing and storage to its preparation, and even to its disposal, how it was thrown away. And you can think about this, take it back to home. Your family probably has a certain way of eating foods. There's certain foods that they eat for the holidays, certain ways that meals are prepared, or even unwritten rules about who cooks or where everybody sits at the table. All of these traditions are part of your foodways and they're tied into identity and culture. In archaeology, studying foodways helps us move beyond simply asking what people ate to actually understanding how food structured daily life, traditions, and even social relationships and social interactions in the past. My research focuses on a major transition in the ancient Southeast, the shift from highly mobile hunter gatherer groups who moved across the landscape with the seasons to communities that began to live in more permanent villages and an increasingly sedentary life. And this transition began around 4,100 years ago along the Savannah River Valley, which today forms the border between Georgia and South Carolina. And understanding how and why this change happened is important because it marks a moment when people began to reorganize their daily lives, how they moved across the landscape, how they cooked their food, and how communities formed around shared places. Earlier, I mentioned that I studied the earliest pottery made in North America. And that pottery is called Stallings ware. It's produced by people that archaeologists call Stallings culture. And this is during the late Archaic period, about 4,500 years ago. Now, to understand this pottery, we need to sort of zoom out to the broader region. And on the map I put on this slide, it shows sites across the Southeast where archaeologists find early pottery, this early Stallings pottery, and shellfish remains. Freshwater shellfish along in the inland areas. So here, let me bust out my laser pointer. So we got freshwater shellfish up in these inland areas, and then towards the coast, this is mainly the remains of marine shellfish, typically oyster along the coast. Now, Stallings culture dates roughly between 4,500 years ago and 3,200 years ago, and it stretches from the middle Savannah River Valley right about here, all the way to the coast of Georgia and South Carolina. And Stallings Island itself, the namesake site of this culture and this pottery, sits at a pretty interesting position in this landscape. It's about right here. It lies near the fall line, which is what that dotted line is there. And it's where the Piedmont uplands and the coastal plain sort of run into each other. And ecologically and culturally, it sits between two different historical food traditions. Along the coast, pottery appears relatively early and is closely tied to large-scale shellfish harvesting, particularly with these oysters we just talked about. And then in the upriver, in the Piedmont, communities are maintaining an older cooking tradition that did not use pottery at all. And we're going to talk about that in more detail. So instead of using this new fandangled technology called pottery that their neighbors on the coast were using, these people that were living upriver in the Piedmont relied on this technology that they've been using for centuries called stone boiling. And it's a cooking technique that's used to heat stones, particularly in this area, they heated soapstone rocks and then placed those heated stones into a container. Now, before pottery was invented or made its way upriver, they would be stone boiling in maybe organic containers, such as a woven basket, or a hole dug in the ground and lined with clay. We see that pretty often, these little cooking features. You could also stone boil in the stomach of a large mammal. I've never done that before, but it is feasible. And I want to note that because of the location of Stallings Island, it really sits at the crossroads where different cooking traditions, materials, and technologies are sort of colliding and almost mixing. And we're going to get into that culture history here in this presentation. So who were these pre-pottery Piedmont people? Archaeologists recognize these Piedmont traditions and these groups living upriver as two closely related traditions. And one is the Paris Island phase, and the later is the Mill Branch phase. And while these phases are slightly different in stone tool styles, they really represent a long-standing cultural tradition in the region rather than completely separate groups. These communities also produce distinctive stone objects called banner stones, which is pictured over here, which likely held both technological and symbolic significance. And if you have questions about that, we'll address it at the end. But what matters for this story is their cooking systems. Long before pottery appeared, these groups used a well-developed method called stone boiling. And they did it with soapstone. And soapstone naturally occurs in the Piedmont, and it's an excellent raw material for retaining heat. It retains heat exceptionally well, and it's resistant to that sort of cracking that a lot of other rock types have. So these heated soapstone slabs, and here are some of the replicas that I made. This is an archaeological plates showing what we see in the archaeological record. You can see these are all fragmented, heavily used. But here's a replica of what these soapstone slabs looked like. And you'll see here in the center that they've got these perforations that were used to get these stones in and out of the fire. So we got a little hole in there. You can stick a stick in or an antler or something like that, and then pick it up out of the fire and transfer it into your pot. And so this soapstone, this really great raw material for stone boiling, occurs sort of at the fall line and up in the Piedmont. So it's a raw material that's readily prevalent in this middle Savannah River Valley region. And this wasn't just a temporary solution. These people weren't just waiting for pottery to be invented. This was their tradition. This is what these Piedmont people did. This is their cooking technology. Their ancestors did it, they did it, and it was really part of their identity and culture. And out here I just have a little graph to show how this works. Stone boiling is not done directly over a fire. That's why it's sometimes called indirect heat cooking. So these stones would be heated up in the fire and then placed into your cooking pot to cook the contents that way, never directly over a fire. So there's just a little representation of what that stone boiling looks like. Now, downriver in the coastal plain, communities lived in a broadly similar time period, and they interacted pretty regularly with people living in the Piedmont. These people were going up and down the river here, and they were in contact with one another, and they were aware of each other's cooking and foodways technologies. So one clue to this sort of connection that we have between these upriver and downriver communities is the presence of soapstone slabs on the coast, even though soapstone does not occur naturally there. These materials had to be transferred downriver from the Piedmont. In exchange, materials also moved upriver. Archaeologists sometimes find marine shell beads, marine meaning they're coming from the ocean, not from fresh water. They find these marine shell beads sometimes in the Piedmont, in sites in the Piedmont, which is really showing that these coastal resources are being circulated inland. And then along the coast, these interactions coincide with the construction of shell rings. And here's an image of Fig Island, which is a pretty famous shell ring site off the coast of South Carolina. Here's an artistic representation of Fig Island. This would be Fig 2, this same shell ring here. And just a sort of a representation of what this community might have looked like, 4,000 years ago. And these sites represent places where people lived, arguably year-round, although research is being conducted as to if these are truly mobile hunter-gatherers or if this is a more sedentary community. But it's also where they held large ceremonies, where they gathered and processed shellfish in mass, particularly those oysters. Importantly, it's a group of people that lived in the round. They lived in a circle. So these are shell rings, obviously, these very circular. And this artistic representation is a little off because they've got, I think those are people. I'm not really sure. Maybe they're posts. But these people were living in the inside perimeter of this shell ring, and then they're accumulating this oyster shell on the outside. So this is really getting at that sedentary thing. This is some of the earlier villages we see here. We've got, people that are living in the round quite literally in arguably increasingly settled villages. Now, importantly, shell rings is where we see some of the earliest pottery in North America of all time. So around 4,500 years ago, the earliest Stallings pottery begins to appear in the coastal plain and coast. And these vessels were thick, they were extremely porous. And part of that was because they were tempered with Spanish moss fibers. They're fiber tempered pottery, tempered with those very fibrous strands of moss. Now, increasingly, they became a little bit more tempered with sand, but to get at that point, I wanna note that these were not used directly over fire. These were used for stone boiling. And over time, pottery began to change. So here's the early Stallings vessel. It's got, pretty flat bottom. It's got a very open orifice and pretty shallow walls. And then over time, about 400 years later, we see a shift in this technology. So the walls get a little thinner. It stands a little taller. It's got a more hemispherical base to it. It also becomes more highly decorated with something called drag and jab punctation, which is sort of a hallmark of classic Stallings pottery technology. But this classic Stallings hemispherical bowl, it's more well suited for direct heat cooking. This is, this rounded bottom makes it easier to nestle into the coals of a fire. The thinner walls conducts heat more easily. This is better suited for direct heat boiling, which is what we typically picture pottery being used for. Whereas these really early, these first potteries, these basins, they're called basins because they're so wide and short. These aren't great for cooking directly over fire. They're very well suited for stone boiling. But interestingly, these classic Stallings bowls that appear on the coast here, when that technology eventually moves upriver, which we'll talk about in a minute, they were never used for direct heat cooking. So even though these Piedmont peoples eventually did adopt pottery, both of these forms they adopted, they never used them directly over the fire. Even they continue to use it for indirect heat cooking through that stone boiling. On this map, I just briefly summarize some of these broader patterns of interaction that we see between these upriver and coastal communities. I just want to note that, materials, technologies, and ideas are moving in both directions. Soapstone slabs and banner stones are moving downriver from the Piedmont, while things like marine shell ornaments and pottery technology and even this new subsistence pattern of living around that we saw at those shell rings, these ideas at least are moving upriver from the coast. And the key point here is that what moved across the landscape wasn't just trade goods, it was practices tied to cooking and food preparation and even community life. At around 4,500 or 4,400 years ago, we begin to see early Stallings groups moving upriver into the middle Savannah River Valley. So they're picking up roots from the coastal plain and coast and starting to make forays into the middle Savannah River Valley, bringing their pottery technology with them. And from an ecological perspective, this makes perfect sense. The coastal plain is dominated by pine forests that produce relatively poor nut crops. While in contrast, once you cross that fall line into the Piedmont, you encounter these really lush hardwood forests that are rich in things like hickory nuts and acorns and draw in all those critters that are feeding off that mast, like deer and bears. Um, because those nut resources are super high calorie foods and they can be stored for a long period of time, which is why it drew in those humans as well. On this slide, we're going to see one site particularly highlighted, and that is Victor Mills. And it's located just across the river from Stallings Island. You can see Stallings Island pictured right here. So they're really in view shot of each other. Instead of those prominent houses, the Victor Mills site contained large storage pits. So in this little plan view right here, all these little dots, those are pit features. They're not all the same. They have different purposes. Some are used for storage. Some are used perhaps for parching nuts to dry them out for long-term storage. And some of these might be, other processing areas. And we also see tools as well. So over here, we've got this really large anvil that was found right over top of presumably a storage pit. So we've got, mass processing technologies on top of a mass storage pit. And by the way, they also found soapstone slab fragment in there and some of that plain fiber tempered pottery from some of these early basins in there. Now, what these features indicate is intensive fall harvesting and food processing rather than a year-round settlement. So it looks like these early Stallings groups were traveling upriver. Maybe just a few members of a community traveled upriver for a few weeks to really hone in on that and that fall resource when those nuts are falling from the trees. And it's also the deer rutting season. So deer are a lot more active at this time in those especially in those hardwood forest areas like we see at the Piedmont. So during this same period, those local Piedmont communities began to sort of reorganize their settlement pattern as well, possibly in response to this increasing interaction and perhaps competition that's happening within this Middle Savannah region. So rather than a simple replacement of one group to another, what we see in this period in this region particularly is a sort of a social negotiation and shifting or maybe a coalescence of identities. Now, by the time we reach the classic Stallings period, about 4,100 years ago, those communities in the Middle Savannah River Valley began forming permanent villages. One example comes from Mims Point, which is located just a kilometer north of Stallings Island. So again, in view shot of Stallings Island itself, but instead of being south like Victor Mills, Mims Point is north. Mims Point is a circular settlement of about 7 or 8 households arranged in around an open plaza. So here we can see the projected household layout here in a circle. These guys representing the possible outline of those houses. And the material culture from this site, namely the projectile or the lithic technologies here, show a pretty strong connection to coastal traditions, sort of suggesting that this coastal life, foodways, and pottery practice had moved upriver and become part of this inland village life. Now, just south of Mims Point lies Stallings Island, which became one of the most important places in this region. This is also a settlement that has a circular village outline. And here's this plan view here. I drew on some symbols of what this household arrangement might look like. And these houses are centered again around a plaza. But instead of being a relatively cleared plaza, with very few features in the center of it. The plaza at Stallings Island is the location of ancestral burials, something that's really not seen at too many other sites outside of this region, except perhaps Lake Spring, which is up the river here. What we also see here is a large accumulation of freshwater shell around the site. So it's an island, so we can estimate that these people are living in the round here, and just like we saw at those shell rings on the coast, they were discarding their shell refuse behind the houses, and sort of accumulating it that way. But because this was an island and it slopes off towards the side, the shell doesn't really stand out as a ring itself. It's more of a midden that just sort of added to this exterior perimeter. It didn't really mound up. It just sort of filled in where these already low and sloping areas. The island also contained unusually large pottery vessels, and this is something called carinated vessels. This is a pretty unique pottery type in the region. Again, not really seen in the area outside of Stallings Island and Lake Spring, that other site that had this really sort of formal ancestral burial area. So these seem to be ceremonial objects, or at least connected with, ancestor veneration or burial in some way. But these are pretty significantly sized vessels, some up to 50 centimeters in diameter. And these bowls are not ideal for everyday household cooking, but they do appear to be pretty well suited for serving. You can see that the lip here on this one, or the shoulder here on this one, is quite different from the hemispherical bowls. It really incurves here, sort of like a punch bowl. Punch bowls aren't great for cooking in, but they are pretty good for serving if you've got a ladle or a cup or something like that. So we did some scientific analyses on these, and it shows that these vessels were made further upriver. And this is the work of Ken Sassman and Zach Gilmore, who did something called neutron activation analysis and petrography analysis on these vessels to determine where they come from. And what they discovered is that these really unique carinated vessels were mostly coming from upriver in the Piedmont, and then being their final resting place was here at Stallings Island. So taken together, the evidence really suggests that Stallings Island functioned as a central gathering place where communities came together to share food, interact socially, and sort of reinforce these regional relationships. Now, across this sequence, many of the most important changes occur not through dramatic political events, but through everyday activities like cooking and food storage. And pottery appears, vessel forms changed, and communities become more sedentary. But that older cooking practice did not disappear. They adapted and incorporated these new technologies with their traditional way of doing things, that stone boiling with soapstone. To truly understand these changes, we need methods that move beyond pottery shape and decoration to examine how pots were actually used, what they contained, how they were heated, and how cooking unfolded through time. And that's where my research sort of steps in. To study foodways archaeologically, I relied on sort of three complementary approaches. One is ceramic analysis, second is organic residue analysis, and the third is experimental archaeology. Ceramic analysis focuses on pottery itself, the shape, how it was made and manufactured, and the patterns of wear from cooking, perhaps. And this helps us understand how vessels were incorporated into daily cooking practices just by the fact that we have different styles. People are making different styles, using different recipes of clay and temper and water to create these vessels. And then organic residue analysis allows archaeologists to identify the chemical traces of food that were processed in these vessels. So we can get a molecular snapshot of what actually was being processed in these vessels. And then finally, experimental archaeology helps interpret those chemical patterns. By replicating past cooking methods, such as stone boiling, I can see how different cooking practices affect how residues form and where they accumulated on the pot. And together, these methods allow me to move beyond simply describing the pottery and what it looks like, and instead focus on how it was actually used by these Stallings people. First is here the organic residue analysis, the chemistry part of this. Archaeologists have studied Stallings pottery for decades, and we know a great deal about it. Important questions remain, however, about what foods were actually processed in these vessels and how pottery fit into the broader foodways of it all. Plant and animal remains recovered from archaeological sites can tell us what people were eating in general, but they don't always tell us what was cooked inside the pot. Organic residue analysis provides a way to address that question pretty directly. The residues preserved in pottery are primarily made up of lipids, which are fats and oils derived from plants and animals, all the things that we eat. And lipids are particularly useful because they survive in pottery for an exceptionally long period of time. In many cases, these residues allow us to distinguish among three broad categories of food resources, and those primarily being terrestrial animals, plants, and aquatic animals. So even though we can't identify specific species all the time, sometimes we can, but definitely not all the time, this chemical evidence gets us a lot closer to how these vessels were being used and what was being made in these vessels than traditional archaeological evidence alone. So how do these residues get preserved in this pottery? The organic residues are these chemical traces that leave behind molecules in the pot itself. As you're cooking your stew in your earthenware pot, that resource is being broken down by that heat, and its molecules are getting absorbed into the wall of the pot itself. And here I've got a sherd of early Stallings earthenware, and you can see it's incredibly porous. And this, that's in part due to the fact that these were tempered with Spanish moss, right? It's fiber tempered. And as that Spanish moss got fired out, as you're firing this pot, it's sort of, caught on fire and carbonized here. It leaves behind these little holes, these little thousands of little wormholes or vacuoles or fissures. So this is in part why it's so porous, but it's also pretty good preserver of organics and the molecules left behind here. So this is just a useful example. There's other ways that lipids and residues can get absorbed within the pot or absorb on the pot itself, but just as a useful example to demonstrate how cooking can result in molecules being preserved in the wall of a pot for thousands of years. Sometimes these residues appear as visible carbonized incrustations on the surface of the pot. In fact, I think that's usually what people think of when they think of residues, residue analysis. But none of the Stallings vessels from the Middle Savannah River Valley have preserved visible residues on them. So everything I discuss in this study is from absorbed residues. To analyze these residues, a small sample of a pot, usually just a few grams, is removed from the vessel. Then the exterior is cleaned off using a Dremel, so it's dremeled off to remove any modern contaminants. And then the sample is crushed into a fine powder. And then that powder undergoes a chemical extraction using a well-established method designed to release the lipids that are trapped in the ceramic itself. That sample is then mixed with a solvent, separating using a centrifuge, and then is further processed to isolate the lipid fraction. Once prepared, the extract can be analyzed using instruments that separate and identify the individual chemical compounds that are present. So after it goes through its chemical extraction and is centrifuged to the high heavens, on top of the ceramic matrix itself. So here, it's almost like you can see the grittiness of that pot here. Here we can see the finer clays. And then on top is where we get these lipids that are being extracted out. And here's these purely these lipid fractions that have been taken out in these tiny, tiny little vials. And just one thing that me and Nora Reber, who works at UNC Wilmington, who is the lipid analyst for North America pretty much, we noticed that the more yellow tinted these lipid fractions were, the more residues they were going to have. So we started calling them juicy sherds. So to analyze the actual residues, that lipid fraction is inserted into an instrument called a gas chromatography mass spectrometer, or GCMS. And this process has two main steps. First, gas chromatography separates that mixture of compounds. The samples move through a long column carried by an inert gas, usually helium. And then as the temperature increases, different compounds travel through this column. Here's the column, circles and wound up along cordage here. So as the molecules are traveling through this column at different speeds, they separate from one another. The second instrument here is the mass spectrometry, and that identifies the compounds. And that's basically what this big bad boy is here. So as each compound exits the column, it enters the mass spectrometer where it breaks into fragments. And the pattern of those fragments creates a chemical fingerprint that can be matched to known substances. So together, these two steps allow us to break apart and identify the types of residues that are preserved in that pottery. This image shows an example of the results produced by GCMS. Each peak on this chromatograph represents a different chemical compound detected in the residue. In this particular case, the overall pattern is consistent with residues derived primarily from aquatic resources, such as fish and shellfish, but it does have some smaller contributions from some sort of plant. Now, importantly, there is no signal consistent with terrestrial animal fats in this sample. So this type of pattern helps us reconstruct the kinds of foods that were produced in these vessels. Experimental archaeology is another key method that I used in this project and continue to use in my projects. In simple terms, experimental archaeology involves replicating past technologies and practices in controlled conditions in order to test archaeological hypotheses. For this study, I replicated early Stallings basins, seen right here. Here's a replica right here as well. And I also made some classic Stallings bowls, which is this one right here and here. And then I used them to cook different types of resources: plant, terrestrial, animal, and fish. The early Stallings vessels were used for indirect heat cooking. So here you can see that I had 4 early Stallings basins designated for stone boiling, and then 4 classic Stallings bowls for direct heat cooking. And in each of these, I cooked the same resources. You'll notice that those are those major resource categories that you can detect with organic residue analysis: plant, terrestrial meat, aquatic meat, and then the 4th one, I did a combination of everything over the fire there. And for the stone boiling, I also replicated these soapstone cooking slabs with these perforations. Here is just some pictures of me doing this actual experiment. So here's what stone boiling looks like. I'm not a stone boiling professional, so I called in the help of a ladle to help me get some of these rocks out. And you'll note over here is just a picture of me monitoring the temperature. So every piece of this study was recorded, how hot the rocks were when they came out of the fire, how hot the rocks were when they came out of the bowl. The temperature of the water itself was all in this sort of controlled experimental study. And then after cooking, in the experimental vessels, I sampled them and then sent them off for organic residue analysis with Nora to apply some of these methods, not only to see what the experimental residues are going to look like, but then compare those results to the archaeological pottery, the Stallings pottery. And this allowed me to directly connect specific cooking practices with the chemical signatures that they produced. The experiments also helped me address questions, other questions in the project, like whether indirect heat cooking produces a different residue pattern inside of the pot than direct heat cooking. That's why I took multiple samples from these experimental pots. I did this with a few of the archaeological samples as well. But when I say the patterning of these residue accumulation, depending on the cooking method, the residues can accumulate in denser numbers in different parts of the pot. So in direct heat cooking, the most abundance of those residues and those lipids is at the top, and then they decrease towards the bottom where that fire is, and that fire is hot enough to seriously degrade residues. So it was my hypothesis that indirect heat cooking and stone boiling with these early Stallings basins, it would have a different accumulation pattern because these pots were not exposed to fire directly at the base. So I was, hypothesizing that vessels used for stone boiling would have higher accumulations of residues at their base than did vessels used for direct heat cooking. Okay, so taken together, I did archaeological sampling and experimental sampling. The residues results reveal a clear pattern in how Stallings pottery was used across both early and classic Stallings periods. Rather than showing a dramatic change in cuisine, the results point to continuity in cooking practices as pottery was adopted in the region. Across the assemblage, residues are dominated by plant and aquatic resources, suggesting that pottery was primarily used for processing foods that had long been a center to subsistence in the riverine and coastal environments here. Or in other words, pottery did not introduce entirely new foods. It was incorporated into an existing food tradition. Also discovered that the lipid absorption pattern of these vessels was also consistent with my hypothesis for indirect heat cooking. So here's a vessel from Victor Mills, that sort of fall resource procurement site that I talked about earlier. And here's the lipid absorption pattern. You can see that the highest number of lipids accumulated at the bottom of that vessel. And here on the left-hand side of that, you can see the results of direct heat cooking. So you can see they're sort of reversed there. So the point of this being, other than looking at the fancy patterning, is that a researcher down the line could be studying pottery, early hunter-gatherer pottery such as this, and they could use this method of sampling in several regions along the profile there and looking at the accumulation pattern to get at how that pot was used, what mode of cooking was used based on those residue absorption patterns. Where the differences do appear, so up here we've got early Stallings and then classic Stallings down here, where we really do see differences start to appear, it's more related to the context of use rather than changes throughout the broad spectrum of everyday cuisine. So some vessels appear to have been used for more routine cooking, while others were associated with communal ceremonial activities, such as those carinated vessels. For example, feasting pits at Stallings Island show a stronger signature for terrestrial animal resources, along with some of the most distinctive biomarker profiles in the entire assemblage, including compounds consistent with materials such as beaver gland secretion and dandelions. In contrast, those large carinated bowls from Stallings Island showed mixed residue signatures and relatively little evidence for terrestrial meat processing. So, combined with their size and form, that supports the interpretation that these vessels were used primarily for serving or presenting food during communal gatherings rather than for cooking it. So, on this slide, I have a picture of Ken Sassman's book, People of the Shoals, which he did his research on, his dissertation research on, has continued throughout his career. Because a lot of what we understand about Stallings culture in the Middle Savannah River Valley really builds on the work that he presented here. And what we see here is that foodways are deeply rooted in tradition, and in coalescent communities, those traditions often persist even as new practices are introduced. So in the study, we can see Piedmont traditions, right? Those soapstone stone boiling, and then coastal traditions, coastal plain traditions of new pottery technology and living and around, sort of coming together here. And in the Stallings case, these long-standing Piedmont traditions of indirect heat cooking continued even as coastal plain communities moved inland and interacted with these upland communities. So pottery, circular village layouts, and new forms of communal gathering were incorporated into existing foodways rather than replacing them. And evidence from coastal shell rings and from Stallings Island suggests that communal food practices, especially shared meals and feasting, provided a setting where different traditions could come together. And in these settings, people from different backgrounds could participate in shared practices while still maintaining elements of their inherited culinary knowledge. Archaeological research often emphasizes the large-scale social change, such as monuments or ceremonial architecture. But by focusing on foodways, this kind of research highlights how everyday activities like cooking and food storage and sharing a meal also play an important role in shaping communities. At Stallings Island, food practices help link people from different traditions, contributing to community integration and the emergence of a new coalescent society. And before I close, I wanted to mention that March is Archaeology Month here in Arkansas. Every year, the Arkansas Archaeological Survey creates a poster and hosts events across the state centered on different archaeological themes. And this year, the theme is historic cemeteries in Arkansas. As you know, cemeteries are everywhere, and many of them are publicly accessible. You can walk through these historic cemeteries, and they can tell you a great deal about the Arkansas past, when people were born, when they died, how large families were, whether children survived into adulthood, and sometimes even personal details about a person's life, like a picture or some inscription on their headstone. And these stones themselves can tell us a lot about life in the region through their imagery and symbolism. And many of these markers reinforce or reference fraternal organizations that helped families cover burial costs during times when funerals and grave markers were pretty difficult to afford. Not that they are all that affordable today. But if you're interested, I encourage you to visit the Arkansas Archaeological Survey's website and check out the calendar of events for Archaeology Month happening all across the state. Okay, any questions?
Thank you, Emily. That was fascinating. I've got some questions and we have time for a few more. You've got two right now. First, from Lauren Adkins in Hot Springs, do you have any advice on how we should preserve and share our archaeological resources and also share information about indigenous cultures from our communities?
Yes. I guess my number one bit of advice would be to do that in collaboration with um, Native American communities in the area. So Caddo and the Quapaw, nobody's going to know their history better than them. So reaching out with them, collaborating with them on the dissemination of that information, and just trying to make some of these materials public. So, one of the major problems, or not problems, but just hiccups with archaeology is that we are curators of items, and oftentimes those curated boxes live on shelves for the majority of their life. And it's important for historians and archaeologists to make local history publicly available to the public so you can see the actual items of their past. Me and my station assistant right now are working on a Pine Bluff history exhibit, just showing some of the objects, these pieces of Pine Bluff that have accumulated since the station existed, and just show, we're touring that to different places. It's going to start off at Sea-Ark College here in Pine Bluff. And then we're going to have just a little like comment box next to it so people can tell me their stories, because I'm a transplant. I'm originally from Michigan. I'm not going to know Arkansas history better than somebody that's lived there their entire lives. So I really want to open up that conversation and learn from the public, and then if I have anything to share with the public, it can be a mutual relationship about learning the history.
Thank you. Is the closest station to Hot Springs at Arkadelphia?
Yes.
Yeah, so you'd be reaching out to Dr. Mary Beth Trubitt,
Yep.
and the Caddo Center is awesome. So if you haven't talked to her, Lauren, I would start there. Okay, Mary Jane Silva in Fayetteville. I wonder if studies of longevity of the peoples who lived in the Piedmont versus the coastal is remarkably different due to the cooking practices.
Yeah, so I'm not a bioarchaeologist, and so I don't know like details about their health per se. Um, but yeah, that would be interesting. How does the diet affect health outcomes and longevity of life?
Okay, my question is, have you analyzed Arkansas pottery yet?
It is currently being analyzed. Organic residue analysis takes quite a bit of time. You can do like a sample a day, maybe. And Nora Reber at UNC Wilmington is pretty much the only person in North America that I'm aware of, or not North America, but the United States. There's others in Canada, that are doing this sort of research. So you can imagine that she's pretty backed up with a number of samples that she needs to do. So it takes some time. But yes, we send out me and Dr. Paige Ford, the station archaeologist at Plum Bayou, Archaeological Mounds, sent off some samples from the training program. Every year, the Archaeological Society and the survey host a training program for 2 weeks during the summer. Where last summer we excavated at Plum Bayou, and Dr. Ford and I have sent off some pottery samples for residue analysis. And we're awaiting results, but they definitely do have identifiable residues in them, which is exciting in and of itself.
That is exciting. I look forward to hearing about that.
Yes, me too.
And then I was going to ask, are there opportunities for the public to volunteer at your station, or how can people get involved if they want to learn more about what you do in archaeology?
Yes, anybody interested in volunteering in archaeology is welcome to reach out to me via my email, which is ebartz@uark.edu. And I can put you in touch with different volunteer opportunities throughout the state. Dr. Ford and I are currently working on revitalizing the Central Society chapter that sort of faded out in the wake of COVID, but trying to get that up and running again. Well, the Archaeological Society will host, monthly events in the central, Little Rock region, where we can, have speakers come in and give, different presentations about research and that, but also just an accumulation of folks that are interested in volunteering. We can go out and do cemetery preservation projects, but Dr. Ford also has open lab days. So again, check out the survey webpage and look at the calendar of events, and you can see open lab days for Plum Bayou, which is just 30 minutes east of Little Rock. Sadly, currently the UAPB lab is sort of infested with mold, and remediation is slow. But once I have a functioning lab, you can all come volunteer with me. I'd be happy to have you.
Okay, thank you so much for a wonderful presentation, Dr. Bartz, and thank you all for watching, and we'll see you next month. Bye, everybody.